Well, today we have two more K7000s with blowing fuses. I acquired these from the operator of the Arcade Legacy up in Cincinnati because I went up there a few weeks back to participate in a Mortal Kombat tournament known as Cincinnati Combat Con, I believe it's what it's called, CKK. This is the third time I've attended the event. It was a great time with great people and played some MK and had a good time. But I was contacted by the owner of Arcade Legacy and was asking about he had issues with his Mortal Kombat 2 monitor and the monitor in his Soul Calibur 2. So MK2 and Soul Calibur 2 both had bad monitors, and he was asking me questions, and I asked him to send me some pictures, and they had K7000s. I said, hey, I just happened to be coming up there, so I brought some K7000s with me I had already repaired, and I told him, hey, I'll just swap you out in exchange for a couple of bucks to cover the cost of repairing the original ones. And you can just give me your bad ones in exchange. So that's what we did. I brought two 7000s to him, got his MK2 up and running, his Soul Calibur 2 up and running. And these are the ones that were in those machines that I brought back with me in trade. And they both have blown fuses. Now, I don't appear to have this fuse, but it was exploded. No, this one was exploded with extreme prejudice. This one, out of the Soul Calibur 2, it actually had a faulty isolation transformer. The monitor was dead, and when I went to look at it, the fuse was intact. As far as I could tell, everything was okay. So I checked the power at the connector, and lo and behold, no voltage at the monitor. So I traced it back to the isolation transformer had voltage going in, but nothing coming out. So once we acquired another isolation transformer and wired it in, we turned it on, and the monitor still had no power. I say that, caveat, we had voltage at the connector now, but the monitor did nothing. After about 3 seconds, boom, boom, the fuse got hot and then died. So there's something bad with this chassis that's causing the fuse to blow. And this one was out of the MK2 originally, and it's very dirty. I'll have to clean all this off and brush it up and all that. I probably should have cleaned it before I did the video here, but that's okay. But this one exploded with extreme prejudice, as you can see here. And the first thing I did was verify that it actually is 2 amps, and yep, 2 amp. So it wasn't an issue of being overrated, but yeah, so we have two K7000s. I'm going to try and get them both up and running here in one video. They both have replacement flybacks. I think somebody tried to just shotgun cap kits and flybacks in here trying to get this resolved, but couldn't, so they just gave up. I'm not sure, but I'm going to turn my little fan on here to blow some of this dust out of my way while I'm wiping this off here. Just so we can at least examine it and everything, because it's pretty filthy here. And I'll go wash, after we get it fixed, I'll go wash it and everything. But for now, just in order to at least visually inspect everything, I'm going to give it a little quick whisk here. I see you eyeing the first piece. Okay, that should be all right. I'm just going to sweep all this off into the refuse receptacle. All right, good enough for at least a visual inspection. Now, let's start with this one. We'll put this one aside for now. Turn this fan back off so we can hear each other. Let's inspect the remote board here. Okay, pots all look okay, nothing's cracked or broken. We're going to put all of them in the middle just for a nominal setting for when we get this working. We don't have anything too far left or right and cause some damage. So sometimes turning your horizontal position too far right or too far left, or even your H hold pot too far left or too far right, sometimes that can cause the HOT to get taken out. But it's not known to happen on the 7000s. More it tends to happen on like the Neotechs and things like that, but it can happen. So we're going to preemptively try and prevent that from happening. So all of our color pots we'll go ahead and preemptively set to the center position. Okay, and some of these are a little bent out of whack. Everything else seems okay. That's an underrated cap there. Should be 250 4.7. And it's just a, oh, it's a 160 4.7, but it's awful small. Well, it looks like somebody has done a complete cap kit with the exception of the bipolar caps here, which I can change those out, that's no problem. Giving it a good look over. Like I say, the flyback has been replaced, and it's super filthy in here. Not sure why you wouldn't clean this before you put it back together. But I'm going to wash it anyway, but just wanted to get that a little clean. Okay, everything appears to be intact. I don't see any caps bulging like one of them was put in backwards or anything, and I'm assuming this ran for a while before it died. And I'm just wondering if maybe the flyback developed a hole or something. I don't see anything obvious on it, nothing from the top or anything. Let's take a look at the back side. I haven't looked at these yet, but yeah, I mean, nothing too bad. Someone did reflow. They did reflow R89. They've reflowed R101. At least that's good. I don't outwardly see anything that jumps out at me as being bad. They've reflowed the video input header pins. Decent job on this, I must say. They reflowed the yoke header pins, but they didn't do D18. Not a big deal, but because the joints look okay. R96 looks okay. Usually those are burned up, but those two are fine. And yeah, I don't outwardly see anything. So let's just go ahead and start probing around here. All right, so first things first, R103. R103 is this vertical ceramic resistor here, and it should read about R103 should read about 2.7 ohms or so. And we'll zoom in just a little bit here. So we'll go to the lead down here by the frame, and then the top lead here should be about 2.7 ohms, and 3.0, totally fine. Now we'll check our rectifier diodes. Usually these only go bad if you hook this up to a non-isolation transformer, but the machine had a transformer in it, so that's not the problem. But we got D19 is good, D20, D21, D22, D24, and D23. Good. R104 should be about 15 ohms. That's this ceramic resistor here. 15.3, totally fine. R189, R101. I blanked on that. It's been a while since I've done this. R101 should be about, it's a 6.5 k ohm resistor, but in circuit it's closer to 5. If it reads somewhere down around 4.0 K, it's usually an indication of our HOT being shorted. So we're looking for about a 4.5 to 5 k ohm. Anything below that is a sign of HOT being shorted. So we get 4.0, HOT is almost assuredly shorted. That's a dead giveaway. 4.0 is almost dead giveaway. It should be around 4.5 to 5. So we'll get to that shortly. R89 should be about 3.9 K, which is this ceramic resistor here. And we get 3.8, that's perfectly fine. R96 should be 1.8 K, that's this resistor right in here. And we get 1.8 K. R88 is another 1.8 K on the other side of R89, 1.8 K. Let's check our voltage regulator. We can do that by going to our B plus resistor on the side. Should be about 180 ohms for the 25 inch, and we get 1.7. So our voltage regulator is shorted also. If you want to check the regulator itself, the red wire and the blue wire run to pins 3 and 4 on the tall, skinny one here. So if we start off on the right here, we go 1, 2, 3, and 4, and we should get the same reading, 1.6. So we have a shorted voltage regulator. We can check C38, our width cap, make sure that it's not bad. And that's these two here. And, oh! Oh, I'm sorry. That I checked the resistor here that's attached to our linearity coil. I need to go one below that. These two. Yeah, it's been a while since I've worked on these. So this one and this one. 130K, that's fine. We're only checking to make sure it's not shorted. D18 is this diode right here across in front of the yoke connector. And we get 0.45 voltage drop. That's fine. We can check D15 and C37. So right in here, right in there, that cap right there, there's a diode next to it. Sometimes those can go bad. You always want to add those to your list of things to check. I believe it's D15. That's fine. And C37, not shorted. It's tied in with the diode. So those are okay. That's something you want to check. The last thing, I guess, for us to check in our circuit, we can check C36, which in this setup is these two individual caps right in there. C69 and C36 when it's dual like that, but they're going to read shorted. One of them will at least because our HOT is undoubtedly shorted, so that one's fine, but I bet you this one's shorted. Yep, there you go. And that's because our HOT is shorted. So you put your negative lead on the middle pin, this is the collector, and then you got the base, shorted, emitter, shorted. We knew that because our R101 read 4.0. So if we take our HOT out of circuit, by just simply desoldering the collector of the HOT, which is the the center one. Remove it out of the circuit, and let's make sure it's not touching the pad. Here is another pad on the same trace. If we touch the pad, touch the center pin, okay, no continuity. So our center pin is not connected anymore, and if we check that same I think this top one is 69. Hang on, diode mode. No longer shorted. The other way around, others C37 no longer shorted. So yeah, HOT is a goner. Now this is an interesting one because it's a 1398, but it's a different package here. This one does not require the insulator, but it's there anyway, which is fine. But our HOT died, most likely because our voltage regulator died. Whenever you have an HOT that's dead, and along with the voltage regulator, 99% of the time the regulator is what's failed and it took out the HOT. If you have just an HOT that died, it's likely something with the flyback or something like that. Because a shorting flyback arcing to the frame, it won't take out the regulator most of the time, but it will take out the HOT. So we're going to have to replace the HOT and likely the regulator, and probably this thing will work just fine. Okay, everything else checked okay. So let's go ahead and remove this HOT. We can just simply, this one has the nut on the back side, which it should, just making sure. And I can't take it out. I haven't desoldered it yet, you numbskull. My skull's very numb sometimes. Let's zoom in so you can see. You nitwit, you lily liver galoot. Gee, Rocky. And yes, I use braid. I don't use a desoldering station. I've had two of them, and they both clog up. They both clog up so bad, I'm just tired of fighting with it. So I just use braid for everything. And that fell right out. There you go, 1398 with a different type of package there. Normally you see keep those out. Normally you see these type in there. This is what we'll put in there. D1398. This is what you normally see in there. This one requires that insulator, whereas this one doesn't. So, but okay, I'm going to keep that towards the top. We've got. I'm going to grab a fuse here. We can put back in there, but we'll use our circuit breaker when we go to do this, so we don't blow through fuses. And then we need a STR3130. So if you didn't know, the 3130s indicate the voltage is on here. So STR 30 and 130 is 130 volt regulator for the 25 inch. Then you have the 123 is 123 volt for the 19 inch. So that's the significance of the difference of that. If you're working on one of these and you see that it's a 25 inch but someone has a 123 in there, they've got the wrong regulator in there. Or if you can't get your B plus to go above 123, that's because they got the wrong regulator in there. So let's go ahead and just put this one in here. Now we can bend this back like so, and then we bend it forward like so. It should look staggered like that. Then you can just, it doesn't need to be completely bent like, it doesn't need to be like that. It can be, but it doesn't need to be. As long as it's not touching the metal here, you're fine. So we'll get this in here, and it just goes right in like so. And we'll get the insulator, and we'll get the screw through here. There we go, and we'll get the nut back here. And it's always interesting to try to get that on there. There we go, and make sure your insulator is straight, and it is. You don't need to screw the ever-loving crap out of this. Just give it a quick torque, and that's it. Once it's tight, that's all you need to do. And then visually make sure that your center leg is not touching the metal, and it's not. And we can go ahead and just solder this back in. And there we go. Get yourself your diagonal cutters here and cut the legs off. You don't want them, I mean, they're not any taller than the heatsink here, but you don't want them to be sticking out and possibly touching the frame of your tube assembly. So, all right, so with that done, let's check and make sure in the circuit it reads good now. We're still in diode mode, and negative lead on the middle, and then each outer leg should be 0.45-ish voltage drop. 0.48. 0.48, good to go. Now let's get rid of this voltage regulator. All right. And we'll desolder this as well. If I could get damn braid out of here, there we go. Whatever happened to Eddie? He's the kid from Mockingbird Lane. Do 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 do. Do 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 do. That should be good enough. There we go. Out with the old, and we can go to pins 3 and 4 here. And it's going to be, I believe, these two here. Dead short. You can't see because I'm a numbskull. Pins 3 and 4. Dead short. And, oh, well, actually, when we're in circuit and we flip it around, yeah, it should be these two, but regardless, yeah, 1 ohm, and then 2 and 3 are also shorted, 37 ohms. So it's dead there, 42 ohms, and then this is the actual across our B plus resistor. That's what we were reading before, 1.5. Now, if we read our resistor, it should be 180 ohms, and we get, oh, hang on, better connection here. 189, close enough. All right, so HOT and voltage regulator, kaput. Par for the course, completely normal, not surprised. So I'm not sure what caused this failure. Like I say, usually a shorting flyback won't cause the regulator to die, but it's very possible. We could get this up and running, and as soon as we turn it on, the flyback could arc, and we'll find ourselves back where we already were here. Okay. But the circuit breaker will save us if it. Well, obviously, if I turn it on and the flyback starts arcing, we can shut it down before anything else happens. Okay, just snug is all you need. Snug is all you need. Snug is all you need. Don't know why I'm doing that. Here we go. 1, 5, 2, 3, and 4. Not bad if I do say so myself. Quick and easy. I'm going to go ahead. I need to go through and do a full reflow on this. So I always go through here and hit D18 and not just reflow, but I will actually combine a big solder bridge across these 2 points just for strength. I do that all the time. That's what I recommend doing as well if you work on these. But don't do it on this side because it's not supposed to connect to the vertical, which are these 2 pins are vertical. The 2 closest together are vertical. The 2 further away are horizontal. But that one's already been done. So in our some points you want to always do are the connections here for your width coil because those can get brittle as well. But I'll go through here and do my usual rework on R101, R89, R96, C38, all the normal stuff I do that I've shown 1,000 times on the other 7,000 videos I have. Or I guess you could say the other 7,000 videos I have. But I think that will get us up and running. Now with that reinstalled, or a new one replaced, let's go ahead and check this again. And 186, which is perfectly fine. Okay, didn't see anything else, nothing else we need to really test before we try this. What we can do is we don't even need to use a picture tube. We can do the old-fashioned way of a little trickery. We can grab a glass jar, put our flyback anode wire in the glass jar, and because we are not going to have the horizontal width coil connected to the chassis, we can actually fire this up without a picture tube and get some high voltage. Caveat here, do this at your own risk. This is not a tutorial on how to do this. It's very dangerous because you still can get quite a shock. This doesn't put out the full 30,000 volts because our horizontal winding is not in circuit on the chassis. But this still will put out a decent amount of high voltage, and you will still get a shock if you stick your fingers down in here while this is running. But you can do this without using a picture tube for quicker and easier testing. So caveat, only do this if you know what you're doing. This is not a tutorial on how to do it. But I'm going to do it here, and you'll see how it happens, but do this at your own risk. Okay, so we can test this. So all we need is our light bulb to mimic the load on the power supply that the picture tube would have. You connect this to the blue wire on your B+ resistor. The other side can go to ground, a 60-watt incandescent bulb. You can use an LED bulb, but it won't give you accurate readings and measurements and a correct load on the circuit that an actual incandescent will. So get some of those. All right, so we need power now. We can just go ahead and get rid of this whole extra connection here that's there for some reason and plug this directly into there. And okay, so we have our power connected. We have our bulb on there for our load. Our anode is in the cup, protected from wandering hands. And as a matter of fact, let's go ahead and connect our meter as well. We can connect our meter to the same location. Volts DC. I'm using black for positive. Yes, I know. We're going to use green for ground because I lost my couple other ones. I don't know where the correct ones went. The correct colors anyway. All right. So we should get about 130 volts for B+, and this should run. The light bulb comes on, we get 130 volts, then this is working. And we can simply try it on a tube the way that it is, and then I'll do all the rest of the off-camera rework. Off-camera, I'll change out these bipolar caps, do the reflow, things like that. But one more thing we need is our 2-amp circuit breaker. I have a circuit breaker here. The part number of this is 7277-2-2. The last number indicates the amperage, so if you want a 3 amp, it'd be -3, a 4 amp, it'd be -4, so on and so forth. 2 amp slow blow circuit breaker, which will mimic the function of the 2 amp slow blow fuse. And I use this to avoid burning up fuses for no reason if something happens. So if something happens, what we should see is this should come out like that. And hopefully it doesn't. All our tests indicate everything should be good. So yeah, unless the flyback is arcing, should work. So let's find out. 1, 2, 3. Okay, there we go. 128, 128.4. This will be closer to 129 something with the actual picture tube, but this is close enough. So there we go. It may not seem like it, but yes, the horizontal circuit is functioning because their HOT is in circuit. So is our flyback. It's not arcing. And if you could put your ear up to the glass here, you can hear ever so little bit amount of crackling from a very small amount of high voltage. Yeah. So this all appears to be good now. So we had a bad voltage regulator and a bad HOT. I think the regulator failed, which took out the HOT. I don't know the circumstance, but usually that's how it happens. But there you go, going in the garbage. There they go. Okay, before we actually test this, let's go ahead and work on the other one. So we can get them both in a situation where they can be tested, and we'll test them one after the other. So this one is now good. I'm going to go ahead and take this fuse and snap it in here. All right, so other than just needing a reflow and some caps changed out, I think this one's going to be good to go. Why it failed, I do not know. Nope. But sometimes it just happens. I don't know. All right, so 1 for 1, hopefully, so far. Now here is our other one. Will it be a case of the same thing? I don't know. And the more I think about this, I don't think that these were ever even turned on with these flybacks, because I think somebody shotgunned these flybacks and cap kits in here trying to get the problem fixed, and it didn't fix the problem. So I wouldn't, if I was a betting man, I'd say these probably never even been powered up with these replacement flybacks because they look brand new. So, okay. Let's start with the same thing here. Let's look at our remote board. Well, this has the P447B, the Bravo for Brown remote board on here, which they're all the same, but it's pretty dirty. Let's just go ahead and try and clean it up a bit. Okay, good enough. And we'll put all these to the halfway point as well. And the contrast pot, yeah, a little messed up there, but that's better. Okay. Each hole's a little messed up too. They've been in the same position for quite a while. All right. Well, there's that. Nick board, all seems fine. We'll put all of our color pots in the middle like last time. Okay, all right, main board time now. This one's a little bit cleaner. It's got the that same different package of HOT in there. It's still a 1398, but I wonder if this one's gone as well. Oh, you know what? I didn't show and tell. Hold on. So I talked about before that R101, if it reads about 4.0K, you know our HOT is bad, which we showed. But I didn't show you what it reads after what it reads with a good HOT in there. And like I say, it should be somewhere around 4.5 to 5K. And you know, if it's 4.0, the HOT is bad, but 4.5 to 5K is what you're looking for. And there you go, 4.5, 4.6, 4.7, 4.8. That's normal. If you had it out of circuit, it'd be right at 6.5K. But, okay, just I forgot to mention that. All right. So while you're doing your power supply testing, you can do a test in R101. If it's 4.0, you already know right away HOT is bad without even testing it. All right, looking at this, they did change the bipolar caps on this cap kit. Don't see anything out of the norm. Okay. Yeah. All right, let's flip this one over. Oh, and they've added some component legs here to beef up things a little bit, which is fine. I'm going to take those off and fix it properly, and obviously this whole corner is busted off, but it doesn't matter because it's still one big large ground plane, so that's not a big deal. And again, someone did a decent job. It looks like they had vertical collapse problems because they've replaced, obviously, someone has done some rework on the vertical IC here. So they've replaced the vertical IC. It looks like they might have replaced R103, but you can see here they've reflowed the video input header pins, and obviously the flyback's been changed. They didn't clean any of their flux up, but they did reflow the yoke header pins just like the other one. So a decent job. Just a little bit lacking on the knowledge and the troubleshooting, and they did beef all this up, which is fine also. You know, you probably could just leave that the way that it is. You could leave this the way that it is, but I'm going to make that a little bit nicer there. Anyway, okay, well, this all looks okay, so don't see any big burn marks or anything. Or anything obvious. So let's go through and test everything like we did before. R103, 2.7 ohms. 2.9, close enough. D19, D20, D21, D22. Can I test this one? I got this glued in there. Yes, okay. 24, 23. R104 is 15 ohms. Yep. And I want to show you something here. Don't get burned like this, no pun intended here. Don't get burned like I have many times before, because if you actually hook up your light bulb to the blue wire and to ground, you now have a pathway to a short. So our light bulb is connected. If I remeasure R104, because it runs directly through the AC circuit, look what R104 reads now. Oh, hold on. You got to have a fuse installed. Let's pretend we have a fuse installed. Okay, look what R104 reads now. What? What? $15. Well, okay, maybe not. So disregard. There's been times where I was troubleshooting these. I was getting like 3 ohms across R104. I took it out and I was reading 15 ohms. Put it back in, 3 ohms. It was big. Oh, hold on. It's not the light bulb. Hold on. It's not the light bulb. Like I say, it's been a while since I've worked on a 7000. And then you know, after you've worked on other stuff for so long, you forget. It's the power. If you connect power, if you turn one of these on for testing, it's not working, and you leave your power connected from your AC, that's what it is. Now, okay. Now check R104. Never mind. I don't know what's... Oh. Man. You got to have the fuse in there. I'm telling you. It's 4th time the charm here. I'm going to get this to read 3 ohms. I'm telling you. I'm going to do it here. There we go. Okay, 7.5. There we go. So if you ever have one that reads 7.5 in circuit, but it reads 15 ohms out of circuit, it's because you left your AC connected. Took a while to get there, but there you go. So don't let that get, you'll chase your tail on that and realize it's all because you left the AC connected. That's the same across other multiple models too. If you're reading odd things on your power circuit, make sure your AC is not connected. All right, where did we stop at? The R104. All right, man. So, are we going to read 4K again on R101? Oh, you can't see. Hang on. I didn't even see myself yet. Hold on. Womp womp. 4.0. HOT bad. It's possible these different package HOTs just aren't any good. Okay, R89 should be 3.9K. 3.6, that's close enough. That's within spec. R88 should be 1.8K. R96 should be 1.8K. We didn't test R97 before, but we'll test it on this one. Should be 270 ohms. 272. They rarely go bad. All right, we got all of that. It looks like someone's replaced C38 and C37. But we'll check all of that. C38. We're just checking to make sure it's not shorted, and it's not. C37 is in the mega ohms, so it's not shorted, so D15 should be fine. Yep, okay, those are good. C30, this is another one that has C36 and C69. I think this, what did I say before? It's C36 and C69 are these two separate ones. I think I may have missaid that in the last one, but on the other one, but that's okay. So again, this one should be good. And if our HOT is shorted, the other way should read short. Yep, another HOT that's bad. Let's check 3 and 4 on our regulator. Should be, 180 ohms. And we get, oh, okay. This regulator is good. We get, on the dial checker, we get 0.15 because we're reading through the resistor. But if we go to actually ohms, it's going to read 180. Yeah, 183. So on this one, it's simply just an issue of the HOT being shorted. So I think that it just failed. But again, that's one way to read it. You can also go again to the two legs on the resistor, and 180 ohms we get. So, gosh, dang it, stay on there. 180 on the nosy. 129.8, so 9.8. So it appears that on this one, everything in our circuit is good except for the HOT. Now, we didn't do D18. Let's go ahead and just check that real quick. Yep, it's fine, 0.48. So it looks like all we got to do here is change the HOT, and that's about it. So let's do that. If that's all, if these both end up working just fine by changing 2 HOTs and a voltage regulator, it's going to be a little bit of an anticlimactic video, but at least again, knowledge refresher for me and for you if this is the first one that you're watching in the series, or if you need to come back for more. It helps us all out. Because after a while, if you haven't worked on something and you start working on it again, you start saying to yourself, it's all coming back to me now. It was so long ago, but it's all coming back to me. With the wind and the rain, and it's all coming back to me now. All right, there's that. Let's check it out of circuit, which we know the answer, but we're checking anyway. Center lead, negative. Other out tube, positive. Dead short. 0.122. Well, it's not good. So another one of these, different package 1398s in the garbage. There it goes. Okay, I left these on hand here on the top so I can easily grab them. I need another fuse too. There we are. Need to order a couple more now. We got one left. Hopefully nothing blows up and causes this to go bad, because I only got one left. Okay, got the fuse. So the way I test these with the light bulb and the glass and everything in the jar, if there was a problem with the horizontal circuit, or the flyback, then it should present itself in this scenario. It should present itself here and not on the tube, or both. So if there was something wrong that would take out the HOT when we use the actual picture tube, it should also take it out on the bench. So that's a good way to test this without having to actually hook up a tube every time. Every time you want to test one of these, you can do it this way without actually having to go through the cumbersome task of on the tube, off the tube, on the tube, off the tube, so on and so forth. Ah, damn it. I usually just grab the little tweezers, but if you do it right and just be lazy, sometimes it works out. Snug is all you need. And no, I'm not singing the song again. So this one appears to just have had a bad HOT, and I don't know, sometimes they just go bad. It's no coincidence they're both bad on both of these, and they're both that weird package. So when in doubt, go to Arcade Parts and Repair. Everything that Peter sells is tested rigorously prior to going up for sale. So that's good. Quick and easy way to test it is to go back to R101, make sure it reads 4.45 or 0.45 to 0.5 k-ohm. And we saw before it was 4.0, here we have 4.7, 4.8, 4.9. Good. Everything else tested okay, so let's grab our light bulb and we'll connect our fuse again. By fuse I mean breaker, circuit breaker. All right, that's connected. Be careful with the bulb. You don't want to bounce the filament around because it'll go out on you prematurely. And if you're testing it like this and you use a light bulb, make sure you give it a few seconds to cool down before you start bashing it around, or again you'll break your filament, not element, filament. Okay, again, doesn't matter which side you put on there, it's just a coil of filament. So blue wire on the resistor, go to the other side, go to ground. Make sure your breaker, or if you're using a breaker, make sure that's installed. Make sure that we have our anode in the glass jar, because if you accidentally forget and you leave this sitting on your chassis and it puts 3,000 volts to something, you're going to have a bad day. So I don't know what the actual voltage is. It's not the full 30,000 like I said, because you have to have your horizontal coil hooked up, but it's still enough to cause problems. So let's grab our meter and we will go ahead and cheat a little bit here and just kind of clip that to that. And last time I used a couple of leads, but this time we'll just try and cheat here. There we go. See, there's that 17 ohms because we're reading through the light bulb. So volts DC, let's grab our power, connect it, and we'll see if it lights up and what happens here. So here we go. We're going to be 2 for 2. Let's find out. 1, 2, 3. Uh-oh, something's not right, because we only have 113 volts. That's not right. This regulator, I think, is probably bad also. If you have a situation like this where everything appears to be working, but you have low B+, I think your regulator is bad, because we tested it. We had 180 ohms at the resistor. We had a 0.150 when reading at the regulator. Everything seemed okay. All the caps have been changed. We have a good functioning power circuit here, but it's only 113 volts. And the regulator says STR 3130, so we only have 115 volts. So we have a bad regulator on this one also. It just it's also failed, but not failed shorted. Well, I'm going to cut away here for the sake of longevity of the video, and I'll come back. We'll have a new regulator installed, and we'll see if it reads 130 volts. Alright, so just like that, we got the suspected faulty STR3130 out. Replacement STR3130 is in there. And let's see if we have 130 volts this time here. So here we go, 1, 2, 3. Oh, ugh, I'm telling you guys, don't get old. I turned 46 yesterday. Don't get old. All right. Take two. Here we go. 1, 2, 3. No. We have some other problem. Interesting. So this might turn out to be something a worthwhile video. Why? That's the correct value, 22 microfarad. This one should be 47. Yes. Let's get rid of this. Maybe it's a bad ground. Maybe we have faulty connections here. And let's try a better connection here. Let's try this again. 1, 2, 3. Nope, it's not the connection. 114 point. So, I falsely condemned the regulator. Let me put this back in the bag that the other ones came out of. So, yeah, I wonder what could be causing that. Let's remove the HOT from the circuit and see what that does. That will tell us if it's something in the horizontal circuit or something in the power supply circuit. So all we have to do is desolder the collector leg of the HOT, which is this in here. Okay, and then make sure that it's not touching the pad. So put the meter in continuity. We'll touch another pad on the trace, touch the pad, touch the pin, nothing. Okay, back to volts DC. Flip this around. Make sure that's still connected. With no HOT in the circuit, we don't really got to worry about putting this in the jar, but we will anyway, just for the sake of security. Reconnect that, reconnect this, put our ground in this hole here, make sure our positive is in there, and let's see if we get 130 this time. 1, 2, 3. No. So it's in our power supply circuit. 117, and the isolation transformer is humming a little bit. So my money would be on, so we can eliminate C36, C69, C38, HOT, or flyback. This is a power circuit issue. It could be the B plus resistor itself, but I don't think so because we're reading 180 ohms. Everything else checked okay. Interesting. Well, let me do some poking around in the sake of, like I say, the video is probably already too long anyway. Let me do some poking around and see if I can find the culprit, and I will come back once I've found it. Alright guys, well this turned out to be a royal pain in the butt, and it's about 4 hours from when I last left you. From just a few moments ago, it's been roughly 4 hours. I've spent 4 hours trying to get this thing tackled, and I think I found the problem, but I won't go into that just now. I want to discuss what I've done here. So just to rule out any possibility of the flyback possibly causing this problem, I removed it. It's sitting right here. But that wasn't the issue. I still had low B+. So to give you an idea again here of what's happening, I'm going to reconnect my light bulb here. And you can witness for yourself what I'm about to describe, because it's easier to do it that way if I actually visually show you what's going on here. So I'll turn this on. 1, 2, 3. Okay, light bulb comes on, and our B plus is only 117 volts. Should be 130, 128 with this light bulb. So we still have our low B plus. Now, if we check all 4 of these rectifier diodes on this side, 1, 2, 3, 4, all 4 should be about 60 volts DC. The top one here, D19, 56 volts. D20, 56 volts. D21, 59. So these two are a bit low. Now these are the readings I'm taking off the other one, the other good working chassis. All four of these are right at 60 volts. Again, 19 is low at 56, 20 is low at 56 because they're both on the same trace here. And then 21 is at 60, 59.3. 22 is only 49. 30, what? 50? See, it's fluctuating between 31 and 35, 36. So something is up with that diode. Now, again, before I get to that, I spent 4 hours trying to figure this out. I overlooked something that is analogous to why this channel is called the amateur channel. I did not start with the basics of a visual inspection, but to kind of tease you, if you want to fast forward a few minutes, that's fine to figure out what it is. But if you're not, if you are patient, let me explain what's going on. So I spent 4 hours trying to solve this problem, and I replaced everything in the power supply section. Replaced, and then if I replaced the part and didn't fix it, I put the original back in, but except for filter cap. I changed the filter cap, left the new one in, but I changed R103, didn't fix it, put a replacement in there, didn't solve the problem, put the original one back in. Same thing for R104, R101, R88, R96, R89, R97. I took all those out, put replacements in on R104 that I mentioned, R104, R105. Everything that has a little black mark or a check mark I have taken out, replaced with a new component, didn't fix the problem, put the original back in, except for the caps. All the caps, C23, filter cap, C57, C56, all those are replaced without, putting the original ones back in. No reason to do that. But I checked C37, C36, C69, C38. I took the linearity coil out, checked these two resistors there, checked the resistors over here. IC2, I changed IC2 out. It didn't fix the problem, put the original back in. Broke the glue loose on the shutdown pot, turned it back and forth and put it back where it was. I mean, anything that I could possibly fathom that might cause this problem, I replaced, put new stuff in, the whole 9 yards. I thought the flyback might have been the problem in some far out notion of possibility. I took it out, didn't fix the problem. We still have low B+. And I just was about to throw the towel in, but I had nothing else really going on. I took a break, watched the game 2 of the World Series. And then I came back to this and spent another 10 minutes or so, and I'm like, man, I got to figure something out. So I took the original, I thought maybe I just had a series of bad voltage regulators. So I took the regulator out of the other chassis we just fixed because I knew it was good at 130 volts. Put it in here, and as you just saw, it's still 117. Usually it's about 116 is what it's been. So I knew it wasn't the regulator. I even slaved in another, I didn't put a check mark on it, not that I need to, but I'll go ahead and do it anyway, I even desoldered the wires off of the 180 ohm B+ resistor and slaved on this one. Did not fix the problem. So it wasn't the B+ resistor regulator, any of the caps, any of the resistors. IC2, it wasn't a shutdown pot problem, it wasn't a horizontal output problem. Something was causing this low B+, and I couldn't figure it out, and I was about to give up on this. I spent like almost 5 hours trying to figure this problem out from when I just left you a few moments ago. I thought maybe the neck board might have had something going on with it. Took the neck board off, it's over off camera. I mean, you name it, I tried to figure it out. And it wasn't until I got to the idea that maybe the rectifier diodes are bad. Again, if we check the rectifier diodes, they're all good for being a diode. 19, 20, 21, 22, 24, and 23. However, given that our D22 reads the lowest of any of our rectifier diodes on the 60 volt reference of what it's supposed to be, I was going to go ahead and just change them all. So I turned it over to start desoldering them. Now I actually already did. I took out D20 and D21 to test them out of circuit just to make sure they weren't part of the problem, and everything checked fine. So then I started to go ahead and go, well, let's just go ahead and pull out D22 and 19 and 23 and 24. And it wasn't until I flipped this over, disregard this line here, this was just a visual separation for me for troubleshooting and testing. It wasn't until I flipped this over that I noticed that on D22, this bottom one here that we're having our low reading on, Look at this. Right there. That's not in circuit. How did I miss that? I spent 5 hours trying to figure this out, and it was right there staring at me this whole time. Even when I drew this black line, I didn't see that. That's not in circuit. So basically we're running this with a missing rectifier diode. Instead of running it with 6 rectifier diodes, we're running it with 5, and that's why our B plus is low. This is not in circuit. You can see here that these two, I think that's D21. D21. You can see here that this side of D21 and D22, they share the same trace. It's this trace here. It's all one trace. If I grab my meter and go to continuity mode and touch my leads together, you can see here that this will go to the pad, but if I touch the pin is no continuity. It's a trace, not pin, the leg, nothing. So our B plus is because we are running this on 5 rectifier diodes instead of 6. This one's out of circuit completely. And if I flip this over and I go to these 2 points here, if I touch this one, we should have continuity to this diode as well on this same trace, and we get nothing. Nothing. So that's has to be our problem, because I am completely out of options here if that's not it. It's just unbelievable that I've never encountered something like this before. So what we're going to do is just simply remove the solder from this. I ran out of braid. With so much desoldering here, I ran out of my regular braid. I have a roll, but I have this thinner, finer stuff. We're going to go through that first here. So I'm going to actually remove this solder from this here. And I'm going to flow new solder on here. And I need to take this diode out of the circuit and clean off the oxidation, but that's going to work. And now if we turn this back around and do that same test with our leads here on continuity mode, is it going to read continuity? Yep. And if we go back and test this again, let's grab this, our light bulb, connect it to ground, connect it to our B plus, and grab our meter, put it on ground here, and go to, well, we want to check our B plus first. Yeah, let's go ahead and put this on volts DC and put that on there. And are we going to get 128-ish instead of 117, 116? Let's find out. 1, 2, 3. Gosh, I just want to slap myself in the face right now. 129.2. I can't believe it. If we go back to these, do we have 60 in all these like the other one? 61, 61, 61, 61. Ugh, I'm just so disgusted at myself. Well, nothing was, I don't want to say nothing. This one had a shorted HOT and a bad connection on the anode, I think is the positive side of D22, and that was all that was wrong with this, and I spent 5 hours troubleshooting something that I should have seen right away. That's why visual inspection is important. I've mentioned it before, and I kind of just got overzealous, I think, with assuming that it wasn't going to be anything like that. But, yep. I'm telling you. I'm just so disgusted with myself, but I'm sure you guys can forgive me. But now I have to put this completely back together. Get the flyback reinstalled. I want to take some alcohol and clean off all these Sharpie marks as best I can. All I really need to do is just reinstall the flyback, and this thing is ready for testing. I need to re-zip tie this here. Like I say, I changed that resistor out. And all that effort and time of swapping these parts out and changing everything out and everything was just a bad solder joint on D22. Yeah. Well, live and learn. So I am going to get this all cleaned up and do my reflow on other stuff and cleaning and put it back together. And then when I come back, we'll be at a point where I have the other one also reflowed and cleaned up. And I need to change out the bipolar caps for the color on the other one. I'll get that done too. Put this back together. And when I come back, we'll have both of these all ready for testing. And yeah, we'll get them tested, make sure everything works. And if so, then hey, we'll call this done. So, man. Well, I guess a good example of when you have a problem like that, don't give up, because you'll eventually find it. Don't throw it in the parts bin. It's got to be something. It's just going to take some time to find it. Even if you overlook it, at least you find it. That's the important part. But I'll get all this work done, come back, we'll have it ready for testing. We'll see how these work on a picture tube. All right, so we have our very first 7000, the one we worked on first, and not the one that I spent 5 hours on trying to figure out, all hooked up here on our U5000 test tube. That's why we have this cardboard thing here so it doesn't short out and all that jazz. And yeah, everything's hooked up. We have our anode, neck, yoke, ground, power, video remote. I even have the meter here set up to read our B+. It's on a alligator clip here and going to the blue wire of our resistor. And everything should be good. We have our trusty Mortal Kombat 2 PCB that we use for testing all of our stuff here. And let's turn it on and see if it actually works. This is the one that was filthy that I actually cleaned up before. I cleaned this up and let it dry while I was working on the other one, so it's all clean and ready to go. And this is the one that had the bad regulator, the blown fuse, and the bad HOT, and that was all that was wrong with this one up to this point. So let's see what this one does. I forgot, I need to set this up here so we can make some adjustments as we need to. There we go. All right, here we go. 1, 2, 3. Okay, it came on. B+ is 130 volts on the nose. Fantastic. Oh, wow, okay. Vertical hold here. There we go. We're way too wide. I'll have to fix that later. But at least it does operate and run. So let's get this on the tripod so we can make some adjustments, see if we can make it look good and better. And we are 130.1. That's fantastic, nice and solid. If I turn up our contrast, like so, it dips down a little bit, but we're staying at 129, 130. That's what you want to see. So, okay. Let's set it roughly back down a little bit. It doesn't matter, regardless. Okay, I'm gonna get this on the tripod. We'll make some adjustments on this one and see if it's gonna last and how good it looks, how good we can make it look, and then we'll move on to the second one, assuming nothing ends up being wrong with this one after all the adjustments. So let me get that done. Okie dokie smoky, let's start out with our horizontal size. We'll get my horizontal width adjustment tool, which looks like this. This is for the G07, but it works for all horizontal coils. And I will try to adjust this horizontal size here on the fly. There we go. And that's pretty good there. Okay, that worked out. Now we need to adjust our focus slightly. Sorry for the refresh rate here. I can zoom in and make that stop, but then we can't see the whole screen. So let me adjust focus here first. Oh man, beautiful there. Wow, okay, fantastic. Looks better in person, obviously. But let's adjust. Actually, you know what? Let's go in the menu. I should have done that to begin with. And we'll go to diagnostic tests, monitor patterns, crosshatch. Okay. We need to adjust this to where the red part is off the screen. That's what you're looking for. So H position, that's about as narrow as I can make the image, because this is not a 7000 yoke, but it's compatible enough to make it run. If this was a 7000 yoke, I see more of the green on the sides by shrinking the H size, but that's okay. Vertical size, we want to be roughly, no, we don't want too much of the crosshatch pattern going off the top, but ultimately I'd say we want to equidistance it, easy for me to say. And ultimately, right about there would be ideal, but then you lose some of the top and the bottom. So let's go ahead and just decrease this to where we see a little bit of the line at the top and a little bit of line at the bottom. All four corners, that's good. I'll say that's fine. We'll go back to the game here and just see how this looks. A little bit of blue in the background, that's what you want to see on a healthy tube anyway. This looks so much better in person, guys. I'm not sure it comes across very well in the camera, but in person it looks really good. We do need to increase our brightness slightly, contrast a little bit. Let's turn our blue down a little bit because it's a little bit too blue, and I'd say that's looking pretty good. And it looks much better in person, a little less washed out and whatnot, but linearity is good, colors are good. And like I say, in person it looks almost perfect. So yeah, 7000 number one looks like it's a winner, if I do say so myself. So okay, I'm going to turn the light back on. I'm going to turn this off. I'll get this chassis off of here, and I'll get this problem one that that kicked my butt, get it installed, and hopefully we'll see how it goes. And we are still at 129.8, so good solid B+. I'm happy with this one. Let's get the other one on here, see how it goes. All right, so our second 7000, the one that gave me all the trouble, is now hooked up. We have our anode, neck, yoke, ground, power, video remote. Everything is ready to go. We got our B+ hooked up as well, just like the other one we just saw. And like I say, this off camera, I did turn it on, and that's when I discovered that if you turn up contrast brightness, the B+ would go way down. And the highest it ever got was 123 point something. And I turned the contrast up, got down like 101 volts or something. But I was like, okay, I got to shut this off before something gets fried. So we're hoping that this works now. I'm confident that it will after finding that D22 out of circuit. All right, so enough dilly-dallying here. Let's go ahead and turn this on, see what we get. 1, 2, 3. Okay, it came on. And we got 129.3, rock solid. Nothing blowing up so far. And okay, this one is, oh, I forgot. I already did some adjustments when I tested it last time off camera, but okay. We're in the same situation I was off camera when I tested this, except now I have a proper 129 volts, 130. If I turn up my contrast now, as you see here, contrast turns up. We're still 128.5, 129.4, and so, yeah, before I was like 101 volts at this setting. Turn the contrast back down to where it's not so much, roughly there. And 129.0, that's perfectly fine, normal for a functioning 7000, a far cry from 101 it was. So it is kind of still fluctuating a bit, but not more than about 0.5, that's fine. So okay, this one is now repaired as well, hopefully. And let's see if I can get this to sit in here properly. There we go, okay. Now the combat continues. So we'll go right to the menu and down to, monitor patterns, crosshatch. Okay, gotta adjust H hold. See how the red is curved off to the right? We can adjust that with our H hold adjustment back this way. There we go. And let's do H position. The dot is gonna be equidistant left to right, which is roughly, I'll say there. Again, vertical size, we want a little bit of the corners of the white pattern visible. Now I need to move vertical position down slightly and increase vertical size slightly. And that seems okay there. I'll give that an okay. Now we got to adjust the horizontal size on this one too. Slide this out slightly, get the adjustment tool in the coil and drive the coil down, and I'll go until it stops moving. There's our green, and it stopped moving. So that's as much width as we're going to decrease. And that's fine. Like I say, on a regular 7000 yoke, you'll see some of the red just like the top and bottom here. So we'll call that okay. H position again. We want to kind of shift this over to where it's a little bit more equal. There we go. A little bit of green on each side. Good. And vertical size. Yeah, vertical position. And now decrease the size because a little bit of red on top and bottom, and decrease our size. Okay, we'll call that good. All right. Now, return to menu. No such number, no such zone. A little bit of blue. That's what you want in the background there. And I dare say that's pretty good right off the bat. A little bit of degauss in the corner, but that's totally fine. Okay, let's turn our, let's go back into the menu, do some brightness adjustments and stuff. So brightness and contrast all the way down. Screen pot up till we get raster lines, or retrace lines. I always get that mixed up. Okay, there's our retrace lines back down till they just go away. Turn our brightness up till the background is no longer black, like so. And then back down till it just goes black, and right about there, turn up our contrast as necessary, and that's pretty good. I need to invest in a better camera, but there's a little bit of blue in the background is what you want. It's a sign of a healthy tube that you're using. That's why I use MK2 here, because I know I'm so familiar with what this should look like that on a healthy tube I can tell you if the tube is good or not. But I just wish this looked better through the camera and the tail end there, because in person this looks really good, almost, you know, factory fresh, perfect. And that's why I also use this tube, because it looks so good. I've rejuvenated it once and it's staying good, but I obviously have no audio hooked up or no soundboard present, but anyway. All right. So, okay, we are 2 for 2 on this 7000 video. Still 129, nice and solid. So, yeah, this threw me for a loop, and I almost gave up on it, but a good example, you know, if you're frustrated, like I was for this for hours, step away for a while, gather your thoughts, come back, look at it with a fresh set of eyes, and that's what I did, and I found the problem. So, keep that in mind when you're working on this stuff. If you get frustrated, put it aside, come back later. You might find your issue right away. Fresh set of eyes never helps. Never helps, I'm sorry. Fresh set of eyes is never a bad thing. It always helps. It's late. It's like 11 p.m. I've been working on this for so long. Just crazy. Anyway, there you go. Thanks very much for watching. I hope you learned something. I know I did. And stay tuned for more, and we will see you next time.